Welcome to one of the most advanced glass factories in the world. I'm Elena, and I've been a process engineer here for 12 years.
From desert sand to windows, screens, and skyscrapers, every step is a perfect balance of science and art.
Glass begins here with silica sand, not ordinary beach sand.
Each grain is a tiny quartz crystal, the same mineral that forms amethyst and citrine. At 1700,
Soda ash, sodium carbonate, acts as a flux, lowering the melting temperature of silica from 17.
Limestone and dolomite contribute calcium and magnesium oxides, making glass resistant to water.
Notice the gray-white limestone on the left, primarily calcium carbonate. The dolomite on the right is distinctly tan pink.
Specialty additives fine-tune glass properties. Feldspar improves workability, salt cake removes bubbles, and
Cullet, recycled glass tape, is our secret weapon. Every 10% of cullet in the batch reduces melting energy by 3.
The batch house is where our recipe comes together. Typically 72% silica sand, 14% soda ash.
Our batch is perfectly mixed, about 500 tons per day, feeding the furnace continuously. Now comes
the melting furnace, 60 meters long, containing 2,000 tons of molten glass at 1,600 degrees Celsius.
Raw batch enters at 1200 degrees Celsius, immediately beginning its transformation. The powder floats briefly on the mold.
The feed rate is pushing the limit on the primary charger.
Backing it off now. Level stabilizing at 40%.
Inside the furnace, batch melts and circulates through 3 zones: melting, fining, and conditioning.
Regenerators capture waste heat from exhaust gases, preheating combustion air to 113 degrees Celsius.
In the fining zone, temperatures are high enough to keep glass fluid while trapped gases escape. Salt cake additives
The furnace never sleeps, and neither does our control team. Operators monitor over 200 per
The pull rate spiked around 0300, but stabilized nicely. Energy consumption is down.
Good. Any issues with the new line?
None reported.
Perfect glass requires perfect control. But the real magic happens in the next room, where liquid fire.
The float bath, birthplace of perfectly flat glass. Inside this chamber, a river of molten glass flows.
At 1100 degrees Celsius, molten glass pours onto 600 degrees Celsius liquid tin. The density difference keeps glass floating. Top machines control glass thickness, from 0.4 millimeters for electronics to 25 millimeters for architectural applications. As glass travels, carefully positioned heaters control cooling rate. Too fast creates stress fractures. Too slow.
Thermal gradient stable. Entry temperature 1000 degrees C. Exit temperature 200 degrees C. Process nominal.
At liftout, glass is finally solid enough to be handled. Specially designed rollers grip the ribbon, lifting it from the
Maintenance crews work in extreme conditions, entering the nitrogen atmosphere to replace top machine wheels or repair equipment without stopping production.
Localized blistering detected on the far right quadrant. Flagging for immediate review.
We've just witnessed liquid glass become solid sheet, but it's still under tremendous internal stress.
The annealing layer. 400 feet of precisely controlled cooling. Here, input stresses in during
Glass must pass through the annealing point at exactly the right rate. Too fast locks in stress, too slow.
After 45 minutes of controlled cooling, glass emerges crystal clear and stress-free, ready to be cut, inspected, and shipped around the world. Casing. High-speed scanners examine every square meter, detecting defects as small as 0.1 millimeters.
Perfect glass has been born. Now it's time to divide the endless ribbon into sheets the world can use.
The crosscutter works in perfect synchronization with ribbon speed, scoring a clean line across 3.2 meters of glass in under 1.
Longitudinal cutters divide sheets lengthwise, creating multiple standard sizes single stock sheet.
Robotic arms handle each sheet with extreme precision. Vacuum grippers exert just enough suction to lift without marking. One wrong move means shattered glass.
For high-performance applications, glass receives specialty coatings. Low-E coatings contain microscopic metal layers that reflect heat while transmitting light.
As demonstrated by the thermal imaging, the low-E coating dramatically reduces heat transfer. It reflects the infrared light.
For architectural and furniture applications, edges require finishing. Grinding removes sharpness. Polishing creates a beautiful finished appearance.
Quality assurance is paramount. Our laboratory tests optical clarity, mechanical strength, and chemical durability.
Polarized light reveals hidden stress patterns. Colored bands indicate residual strain that could affect optical performance or long-term durability. Mechanical testing verifies structural integrity. Bend tests confirm glass can withstand wind loads and impact forces required by building codes. Thermal shock test. Sample alternated between hot and cold chambers. Testing resistance to temperature stress, critical for architectural and automotive applications. Every element is verified. Composition affects color, durability, and workability. Finished packs travel to packaging globe. Each stack carefully labeled with size, thickness, quality grade, and production lot for complete traceability.
Our warehouse holds 30,000 tons of finished glass, organized by size, type, and destination.
Implants. Glass shipping requires specialized equipment, air ride suspension, proper securing, and careful handling.
All right, everything is secured and confirmed.
From factory to facade, our glass travels to construction sites, fabricators, and manufacturers around the world. Glass manufacturing has transformed environmentally. Advanced emissions control, heat recovery, and waste recycling minimize our footprint.
The future of glass is extraordinary. Smart glass that darkens on command, ultra-thin displays,
Behind every sheet of glass are the skilled professionals who make it possible. Engineers, operators,
What a milestone. Congratulations, team.
What an incredible journey. From ancient sand to the transparent material that defines modern life. I'm proud to be part of this timeless craft teams and grateful you joined us behind the scenes. Please subscribe.